And, oops, this is not your class. This is your class. Today we're going to look at that last topic in the chapter that we're working on. Chapter 10, it's dealing with systems of equations. Homework 16 and 17, which are on what we looked at last class, the functions and the graphing inequalities, are to be done by the end of the day today. And then homework 18, which is what we're working on today with systems of equations and problem set 2, are to be done by the end of the day on Tuesday. Problem set 2 is a preparation for exam 2. And so what'll happen is exam 2 will be after class Tuesday. I'll have it available from about 1 o'clock on Tuesday until midnight Wednesday. And you can work on it on your own time. You must submit pictures of your work. I am not going to grade anything that does not have pictures of your work. You must submit pictures of your work. And I was thinking on Tuesday, starting the class by going over a practice exam to get everybody in the right place for taking a test. When we went over that problem set before the last test, when we went over that practice exam, did that help you guys or no?
Yeah, I liked it. I did.
Something like that. Before we get started looking at these systems of equations, let's do a real quick review of what we've done so far this unit. We've looked at the plane and plotting points. How does everybody feel about plotting points? Are we okay with that?
Yes.
Then we looked at graphing an equation by making a table of values. And remember, we said you can substitute any 3 values that you want. Usually for X, you solve for Y and plot the points. How does everybody feel about that, making a graph by making a table of values and plotting points? Is that something we can all do? Okay, being met with silence, can I assume that that means everybody's okay with it?
Yes.
Yes.
Then after that, we looked at the intercepts. And intercepts, we set our points. And because they're points, when we talk about them, we need an X value and a Y value. They're on the axes. And it's where the graph crosses the axes. If you're looking at a graph, you can get them by inspection. If you're not, we had said that if I want the x-intercept, the x-intercept is a point of the form a0. The y value is 0. So we substitute y equals 0 to find it. And to find the y-intercept, because it's on the y-axis, it's a point with 0 for the x value, some number for the y value, and we find it by substituting x equals 0. And that gave us the intercept method of graphing lines by just finding those intercepts, plotting those 2 points and graphing the line. Then we looked at the idea of slope, which measures the slant of the line. And we had said that when we look at slope, the definition of slope is rise over run, which is the difference in the y values over the difference in the x values. It's a number. It doesn't have a variable attached to it. It's just a number. Usually it's a fraction. And if it's positive, We said that our line is increasing. If it's negative, we said that our line is decreasing. If it's 0, we said we have a horizontal line. And if there's no slope, we said we have a vertical line if the slope is undefined. We use that then to find the equation of the line using the point slope method. And the point slope is y minus the y value of the point is equal to the slope times x minus the x value of the point. So that m is the slope, and x1, y1 is a point on the line. And we just kind of substituted into that equation, that formula to find the equation of a line. Point slope formula, we stopped there. Then we said if we go through and take that and solve it for y, we get the slope intercept form, which is our y equals mx plus b, where m is the slope and b is the y-intercept. And that gave us another way of graphing lines. In addition with slope, we said that parallel lines have the same slope, the same or equal slopes. And we said that perpendicular lines the slopes are negative reciprocals. In addition to the y equals mx plus b, we had two special cases of lines. And if we had a line where it was just x equals a number, we said that that's going to be a vertical line. All the points that have the same x value lie on a vertical line. And we said if we have y equals just a number, it's going to be a horizontal line. At which point I want to stop for a second. And somebody emailed me a question that they were wondering about. Let me go here. Let me go here. Somebody had sent me a question. I have no idea what that toolbar is that's showing up right now, but it's showing up right where I don't want it. And I haven't had it before in Zoom, so I don't know what's going on. The question was to identify the appearance of the graph y equals 1/6. And if I look at that graph, do you see how it's, excuse me, do you see how it's, where it's y equals 1/6? There's no x. If I were comparing it to y equals mx plus b, because there's no x, that b is 1/6. So this is going to be a line that crosses the y-axis at whatever place 1/6 would be. Because it has no x, we could say that m is 0, which means it has 0 slope, or it just means that it's going to be a horizontal line. And so anytime I have an equation where it's just y equals a number, it will be a horizontal line. So let me clear that.
Thank you.
If I have an equation, let's say, for example, y equals -7. Because it's y equals, the slope is 0, and it's just going to be a horizontal line that could go to -7 on the y-axis, and all the y points that have a y value of -7 will be on that line. Instead, if I had something like x equals 2, there we have no y at all, so we can't even think of a slope because it's nowhere near that form. So I'm going to go to that 2 on the x-axis. And every point that has an x value of 2 is going to be on this vertical line. And so you need to remember, if it's just x equals a number, it's a vertical line. If it's just y equals a number, it's a horizontal line. If you can't remember that, I guess you could make a table of values. X, y, and our line is y equals -7. So it doesn't matter what I put in for x, the y value is always -7. And if I look for all the points with a y value of -7, they'll be on the same line. And this one, where it's x equals 2, at x equals 2, it tells me my x values are always 2, no matter what my y values are. And that's what gives me that when I look at points like that vertical line. Does that make sense?
Yes, thank you.
Yes. Okay. That was the only question that I remember receiving via email from this class since last class. But I'm on a roll, so do you guys want me to carry on with this review of everything we've done thus far? Or am I wasting your time?
I think review is good, but anyone else?
The other thing that I would want to talk about is the inequalities. And if I have ax plus by is less than c, or ax plus by is greater than c, strictly greater than, strictly less than, you have to remember that those are your dotted lines. If I have ax plus by is less than or equal to c, or ax plus by is greater than or equal to c, those are your solid lines. And in addition to graphing that line, either dotted or solid, you have to remember to take a test point and then shade. Was everybody all right when we ended class with that on Tuesday? The other thing that we talked about on Tuesday is a function. And for a function, what's important is that each x value is used only once. We talked about the vertical line test. The idea that if I'm looking at a graph, I'll know it's a function if a vertical line can only cross it in one point. But what's important that you really wrap your mind around is that idea of function notation. And the idea that f of x is just a fancy way of writing y. F of x is the y value. And so if I have something like f of x equals 2x plus 1, and I ask for something like f of 3, can anybody remember what we were supposed to do with that 3? Looking at where I wrote the 3, do you see how I put 3 in the spot that the x used to be in? So when I look at f of 3, it means I want to replace the x with 3. And then I'll evaluate. And so this is like saying that when x is 3, y is 7. So again, let's say I have another one. Let's say I have f of x equals 1/2 x minus 4. What that really is saying x is a placeholder. F of whatever I put in parentheses is 1/2 of what was in the parentheses minus 4. The variable is like an empty space, a placeholder. So if I want f of 10, that would be 1/2 times 10 minus 4. Half of 10 is 5 minus 4 is 1. And so if I say that f of 10 is 1, which I get by substitution, that's saying that when x equals 10, because I put in 10 for the x place, y equals 1, because f of 10 would be the y value when x is 10. And so it's just that idea when we have that letter notation for a function, for a rule for a function, what goes in the parentheses, the number that goes in the parentheses or the expression that goes in the parentheses is what I'm substituting for x on the other side. Is everybody all right wrapping their minds around that?
And for 10, you just chose that as the number.
I just made it up.
Okay, thank you.
Okay. Now, before class, I took the liberty of looking in my labs, and I noticed that a lot of people aren't real caught up with their homework. And so, oh, I didn't mean to open that. And so I want to just take a minute and ask, is it time that people aren't being caught up with their homework, or is it content? Is the material difficult? Does anybody want to look at any problems from any of the homework before we begin today? Does anybody have any questions on any of the questions? Can I do anything out with you guys? Can I go over any problems with you before we add one last new thing?
I don't have any at the moment other than that one, but if I have more, I can just use the homework help thing. And then do you prefer us to try to work through it ourselves with the?
I'll tell you what, if that is up to you. If it's better for you to go through yourself with the Help Me Solve It, if you learn better doing it on your own, go that way. However, if Help Me Solve It phraseology only serves to make you confuse you and make you feel more lost, don't use it. Send me an email. Whatever's easier for you. If it's easier for you to use the Help Me Solve It because you get an immediate response, go for it. If it's easier for you to get an email from me, if me putting it into my words helps you more, send me an email, but realize that email, I try to reply quickly, but I'm not as immediate as the Help Me Solve It. And so I guess it's a matter of personal preference, what works best for you when you reach out for help. Do you know what I'm saying?
Yep, thank you.
I'm more than happy to respond to your emails, but if you'd rather use the help function, I won't be offended. But if you'd rather get an email from me, go for it. How's that sound?
Good.
Yeah. So anybody else have any questions on any of the homework?
Nope.
No? All right. If not, then what we're going to look at today are systems of equations. And we're going to really just look at systems of linear equations. And so if I look at a system of linear equations, oh dear. When I have a system of equations, it's when I have more than one equation. And so an example of a system of equations might be something like 2x plus 3y equals 5, and x plus y equals 1. And so I've got more than one equation. I have two equations. We will be looking at systems with two variables, x and y, and if we have two variables, we need two equations. As you progress in your mathematical career, you'll find that you have to have at least as many equations as you have variables. But again, we're going to be looking at, this would be a system of two equations in two variables. And what's important to know with these is a solution must satisfy all the equations in the system. So if I look at that system above, I might ask, is 2, -3 a solution of the system? And the way in which I'm going to check is I'm going to substitute into both equations. So the first equation is 2x plus 3y equals 5. The second equation is x plus y equals 1. And if my point is 2, 3, is everybody all right? That means I'll be substituting x equals 2. And I'm sorry, it's not 2, 3. I read it wrong. It's 2, -3. I'm substituting x equals 2 and y equals -3. So in the first equation, I have 2 times x is 2, plus 3 times y is -3. Using my order of operations, that becomes 4 minus 9, or -5 equals 5. Is that true? Does -5 equal +5?
No.
No. Since that's a no, I don't even have to do the other check, because in order to be a solution, it's got to work in both. So instead, let's try another value. Let's try, is -2, 3 a solution? And so I've got 2x plus 3y equals 5, and x plus y equals 1. And this time, looking at the point, we would substitute for x the x value, -2. We'd substitute for y the y value, 3. And so that gives me 2 times -2 plus 3 times 3 minus 4 plus 9. Does 5 equal 5? Does that one check? Yes, but that's not enough. It's got to work in both. So now, because I got one yes, I'm going to substitute in the other. X is -2, y is +3. -2 plus 3 is 1 equals 1, and it checks. And so now this answer is yes, it's a solution because it works in both. Works in both equations. And so the idea, if I have a solution, it has to satisfy both equations. Everybody okay with that? Hearing nothing, I'm going to hope that means that everybody's all right. Do you need to wait me for you? Do you need for me to wait a minute for you to catch up writing? Or are we
Yeah.
good?
Yeah. 1 second.
We're set?
1 second.
Okay.
So you mean when you say it works in both equations, you just use the variables to solve them for each?
You take
Oh, you gave me two. There's two equations there. Yeah. Okay. Got
the
it.
two equations. You'll be given two equations, please. And you have to check in both. Checking in one is not good enough. Unless if the first one tells you no, then you know the answer is no. But if the first one tells you yes, you've got to go ahead and check in the second one too. You need both of them to be yeses. All right?
Yep.
If so, we know how to check, but now we have to know how to solve. And we're going to solve systems. And again, we're going to look at two equations. By graphing. So we're going to solve systems graphically. And so the first thing we're going to do is graph the first equation. Then, after we have that first one graphed on the same axes, we're going to graph the second. And so then we should have two lines. And what's cool is the solution. If it's got to be a part of each equation, it's got to be on each line, which makes it so that the solution is the point of intersection of the two lines. And then, like all good mathematicians, we want to make sure we got it right before we put our answer in, so we have to check. But again, like we said before, we have to check in both original equations. And so in looking at these systems of equations, we're going to have a lot of practice graphing our lines. And we're going to see that when we graph our lines, three different things could happen. Everybody have the method down. Can I turn the page?
Yep.
Okay. So let's look at a few examples. First example, let's solve the system. Let's look at x minus y equals 2 and 2x minus y equals 3. The first thing that we want to do is graph both lines. And so I'm going to draw myself a set of axes. Label the x, label the y, put a couple points, a few values on each. And now I'm going to try to graph both lines on that axis. First line is x minus y equals 2. I guess if you were a glutton for punishment, you could make a table of values to graph them. But I'm going to use the slope-intercept method. And again, to use the slope-intercept method, the first thing I need to do is solve for y. So in order to get y alone, I'm going to subtract x from both sides, giving me negative y equals, and as I look at this, these are not like terms, so does everybody remember I have to leave them separate? I'm going to write that as negative x plus 2. Now, to completely solve it for y, we need a leading coefficient of 1 on y, or because there's a negative sign in front of the y, I know that I have to divide both sides by negative 1, giving me y equals negative x, negative divided by negative is positive x minus 2. When I compare that to my y equals mx plus b, going in alphabetical order, does everybody see that b is negative 2? So this line is going to begin at negative 2 on my y-axis. And then looking, there's no value for m, so m is 1. I always want to change that into a fraction. So that's 1 over 1. And because it's positive, it tells me I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. I do that a few times just because I'm not real good at drawing a straight line. So hopefully the more points I have, the better my line will be. And so this is that first line, x minus y equals 2. How is everybody with that process using the slope and intercept to graph a line? Hearing no complaints, I'm hoping that means it's all right. And so my next line is 2x minus y equals 3. So again, I'm going to try to get that y alone. I'll subtract 2x from both sides, giving me negative y equals negative 2x plus 3. And again, I don't want negative y. I want positive y. So I'll divide both sides by negative 1 and get y equals 2x plus, I'm sorry, that's not plus. Positive divided by negative is minus 3. Comparing it to y equals mx plus b. Alphabetical order, I'll start with b. b is negative 3. b tells me where to begin. So I'll begin at negative 3 on my y-axis. M, the x coefficient is 2. As a fraction, it's 2 over 1.
That construction.
Say that again. M is 2, and so that means my slope is positive 2. So from this point, I'm going to go up 2 over 1, up 2 over 1. And when I connect the points, again, my picture's a little off, but you see how over here, they cross at the point 1, negative 1. And so that point that's common to both, 1, negative 1, should be my solution. And so what we did here was we graphed both lines and we said, do they cross? Where they cross is my solution. And so now when I go to do a check, first line is x minus y equals 2. I'm checking that point 1, negative 1. So I'm putting in 1 for x and negative 1 for y. 1 minus negative 1, using my rule for signs, is 1 plus 1. 2 equals 2. So it checks. But that's not enough. It also has to check in the other equation. 2x minus y equals 3. So 2 times x is 1 minus y is negative 1. Does that equal 3? Well, that's 2 minus a minus becomes plus. 2 plus 1 is 3 equals 3, so it checks. And so since it checked in both equations, it's a good solution. How's it look? Shall we try some more?
Yep. Will we have the same amount of time for this next test? Because I feel like this would take me longer.
There will also be 4 questions on this next test. But yeah, you'll hit the same amount. Next example, let's look at y equals 3x minus 10 and x minus y equals 6. We're solving it graphically. And so I'm going to draw my set of axes. My first line is y equals 3x minus 10. Y is already alone, so I'm going to compare that to y equals mx plus b. What would you folks tell me b is?
It's the y-intercept.
Y-intercept, it's negative 10 in this equation, so I'm going to go to negative 10. On the y-axis. M is 3 as a fraction. It's 3 over 1. It's positive 3 over 1. So I go up 3 over 1. Up 3 over 1. Up 3 over 1. And hopefully those are enough points to draw a relatively straight line. My next line is x minus y equals 6. This time the y is not alone, so we're going to have to solve for y. To do so, I'll start by subtracting x from both sides. So I get negative y equals negative x plus 6. But I don't want negative y, I want y. So I'll divide both sides by negative 1, which gives me y equals x minus 6. So here, b is negative 6, and I begin at negative 6 on the y line. M is positive 1. I'll think of that as 1 over 1. So from here, I'll go up 1 over 1, up 1 over 1, and I've got my point of intersection. And so my intersection is the point 2, negative 4. And so that would be my solution. If I check y equals 3x minus 10, the y value is negative 4. Does that equal 3 times 2 minus 10? Or does negative 4 equal 6 minus 10? Yep. The other equation is x minus y equals 6. When x is 2 and y is negative 4, that becomes 2 minus negative 4, which is the same as 2 plus 4, which does equal 6, so it checks. This really isn't a lot different than what we've been doing, but for each problem, we just graph 2 lines and see where they cross. How's it looking?
I don't understand how you have multiple points, like the dots.
Okay, over here, let's look at that first line. The first line, b is negative 10. So I'm starting at negative 10 on the y line. Is that all right?
Yes, yep.
Now, the slope is 3 over 1. It's positive, so I go up 3 over 1. So from this point, I go up 3 over 1. That all right?
Yep.
In my labs, that's enough to graph the line. But because I'm not in my labs and I'm doing it by hand, I'm just going up 3 over 1 a couple of times. Up 3 over 1, up 3 over 1, just so I hit more than 2 points to draw my line.
Okay.
Okay?
Yep.
All right. 2 more examples, and they're carefully chosen to prove a point. First is y equals x plus 5, and the second is 2y equals 2x plus 4. I'm going to draw my axes. First line, y equals x plus 5. When I compare it to y equals mx plus b, b is 5. So I begin at 5. M, the number in front of the x is 1. So that's 1 over 1. So from this point, I go up 1 over 1. And again, because I don't have a real steady hand, I'm going to do it a couple of times so I have more than 1 point. In my labs, you only need the 2 points. Second equation is 2y equals 2x plus 4. The y term is alone, but it has a coefficient. So let's divide both sides by that number 2. That gives me y equals, and remember on this other side, I have to divide both numbers by 2, giving me 1x plus 2. When I compare that to y equals mx plus b, b is 2. So I begin at 2 on the y-axis. M is 1, which would be 1 over 1. So from this point, I go up 1 over 1, up 1 over 1. And when I connect the points, again, I apologize. I should probably be using a line tool in which to draw this. I'm sorry. But they both have a slope of 1. So since they have the same slope, even though my picture is a little wiggly wobbly because I can't draw, do you see how that they're parallel lines? They never cross. If they never cross, I'll never get a solution. And so this system has no solution. If a system has no solution, it's considered inconsistent. And don't be surprised if there might be one on the homework where there is no solution, where you have an inconsistent system. You can get it by seeing that your lines are parallel, or if you're a little bit lazy, once I have my lines in slope-intercept form, I could look at those two lines and say, hey, wait a minute, they have the same slope. They have the same slope, but they're different lines, so I know they will be parallel. And I have this inconsistent system, no solution. All right? If that's okay, my next system is y equals 1/2 x plus 3. And oh my gosh, did you guys hear that? When that popped, it was so loud in my headphones, it was driving me crazy. I think my heavy hand landed on something that it shouldn't have. So let's have y equals 1/2 x plus 3. And let's have the other equation be 4y minus 2x equals 12. I'm going to graph this line first, where I compare it to y equals mx plus b. Does everybody see y's alone? So b is 3. So when I go to graph this line, we begin at b. M is 1/2. It's positive. So from this 3, I'm going to go up 1 over 2. Up 1 over 2. And so there is my line. Everybody comfortable with that line? Next line, we have to do a little bit more work. We have 4y minus 2x equals 12. We have to get y alone. So first I'll move the x to the other side by adding 2x. On the left, I'm left with 4y. Over here, these are not like terms because one has an x and the other doesn't. So that gives me 2x plus 12. And then to solve for y, we want that coefficient of 1. So I'll divide both sides by 4. And that gives me y equals 2/4 x plus 3. Oh, 2/4 is a half. Y equals 1/2 x plus 3. Does that look at all familiar? Begin at 3, go up 1 over 2, up. Hey, aren't they the same lines? these points intersect, these lines intersect everywhere on the line. And so there's an infinite number of solutions. It's a dependent system. So the solution set would be the set of all points x, y, such that y equals 1/2 x plus 3, or all the points on the line. And so when we look at these systems of equations, there's three possibilities. My lines could cross once, and I have a single solution. My lines could be parallel, and I'll have no solutions. Or my lines could actually both be the same line, and I'll have an infinite number of solutions. How cool is that? But if you think about it with two lines, that's what could happen. They could cross, they could be parallel, or they could fall right on top of each other and be the same line. Again, if they cross in one point, I'll have one solution. If they're parallel, I'll have no solutions. And if they fall on top of each other and they're the same line, I'll have infinite solutions. All the points on the line. So, again, the systems of equations isn't a heck of a lot different than what we've been doing. It's just that graphing lines is so much fun that we want to put two of them in the same picture. So, any questions? Oh dear. And I went to this view to see if I could look at you guys and see your faces and see if anybody has any questions. But nobody's showing, some people are showing me lovely pictures of themselves, but nobody's showing me their face today. So I need you guys to tell me some words. Is this stuff okay or no?
I personally
Yeah.
would have to do some more myself, like, and then I know I would have questions.
Okay. All right. Again, that's the last of what's new in this unit. I don't want to start reviewing until you have a chance to practice a little bit more. I agree with you, Lynette. Practice always makes things better. If we were on campus, I would give you the remaining hour to work on your own, and I would walk around the room and help you. Since we're not all in the same room, that's difficult. And so I will leave it up to you. If you want to stay in Zoom and work and have me intervene where needed, fine. If you want to work on your own, next class, we will answer what questions you have and go over a practice test. and then do a tiny bit of introduction into that next section that we're looking at, which deals with the idea of exponents and polynomials. And after next class, before class day, you will have that test to do on your own. So anybody have any questions right now? And again, do you guys want to stick around and work on the homework and have me be here if you need help? Or if you want to call it today a day, that's fine too. What are you thinking?
I'll call it a day. I'll just
You're
work on it on my own, Chris,
Yep.
and hopefully I'll be okay.
Okay, how about you, Lynn?
Yeah, I'll work on some of the homework and then I know I'll have questions, believe me. So sorry in advance if I email you a bunch of questions.
Don't apologize me. That makes up for me missing seeing
Okay.
you guys. It's perfectly fine. No. Megan, how about you?
I think I'm just gonna go and do it on my own.
Okay, all right, Jeremy?
I'm gonna try and do it on my own.
Okay, all right. Shakira?
I'm just gonna do it on my own.
Okay, all right. Adrian, how about you? Adrian? Okay, Lucas, how about you? Oh, Lucas is, yeah, no, Lucas, you're still there. How about you? Am I correct that Susan is Lucas? Not gonna answer me. Albert, how about you?
I'm probably gonna stick around for a minute.
Okay, all right, well then I'll wait. So, but if you want to just work on your own, have a good day and don't feel like you need to hang around. Okay?
All right,
Thank you.
You're working on your own, right? You had said that before?
Yep.
Okay, all right, have a good one, you guys.
Thank you, you too.
Okay, talk to you later.
Talk to you later.
Bye.
Bye.